So the topic we'll be discussing in this session is indirect TCP. So it is it is basically comes under classical TCP improvements. So here we'll be discussing a concept called indirect TCP to support mobility. So what indirect TCP does in the sense, it basically segments a TCP connection into two parts, into a fixed part and a wireless part. So the fixed part uses the traditional TCP, standard TCP, and the wireless part it uses a special TCP which is adopted for wireless networks. Okay, so in this diagram you can see there is an access point, and the connection between the access point and this computer. Here let us consider this computer as the CN, that is the correspondent node. So the communication between the access point and this CN will be through traditional TCP. Okay, the communication between this computer and this access point will be through traditional TCP. Okay, whereas the communication between this mobile host and the access point, the communication between the mobile host, this can be considered as MN mobile node, and the access point, this will be through wireless TCP. Okay, so basically it splits the TCP connection into two parts, and it uses wired TCP at one end and wireless TCP at another end. Okay, and and there is a access point which coordinates this. Okay, so with respect to cn, this is the mobile node. Cn will see this access point as the mobile node, right? Cn don't know about there is a mobile node here and that is connected through wireless TCP. All this Cn don't know. The correspondent node assumes that this is the mobile node and it will send the packet. Okay, and this access point, whatever the packet is transmitted from the correspondent node, for that it will send the acknowledgement, and then it will send the packet to the mobile host through the wireless link. Okay, similarly the mobile host will consider uh, this as the correspondent node. Okay, so for the mobile host, this access point is the correspondent node. Mobile node does not know that this access point is connected to the actual correspondent node through a wired network. These things mobile node does not know. Okay, they don't know. Mobile node sees this access point as the correspondent node, and the correspondent node sees this access point as the mobile node, and that is how the communication happens. Okay, now the mobile host or the mobile node, if it wants to send any packet, it will transmit the packet through the wireless link to the access point, and for that access point is the CN. It assumes access point as the CN. It don't know anything else more than that. Okay, and the CN and the access point will now send acknowledgement to the mobile host. The access point will send acknowledgement to the mobile host, and then it will retransmit that packet to the actual CN. Okay. So this is how the communication happens, right? If there is any packet loss, okay, mm, assume that uh, 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 assume that there is a packet P1. The packet P1 is sent from mobile host, and it has reached the access point, and the access point has sent acknowledgement for that. Okay, the access point has sent acknowledgement for that, and then it has transmitted to the correspondent node. But during this transmission, this packet has lost. This packet has lost. Okay, now the access point itself will retransmit this packet. Now the access point itself will retransmit this packet because it will maintain a buffer and it will store that. Okay, and the mobile host does not know anything about the missing of this packet. Okay, right? Similarly, if there is any packet missed in the wireless link, okay, say for example, this correspondent node is sending a packet P2 to this access point, and the access point has received this packet successfully, and then it is sending the same packet P2 to the mobile host. But this, while sending P2 to the mobile node from the access point, while forwarding this P2, before forwarding this P2 to the mobile host, it will send acknowledgement for P2. Okay, it will already send acknowledgement for P2, and then it forwards. But while forwarding, this packet got lost. Okay, so now there will not be any acknowledgement for that. So the access point will understand and access point itself will retransmit this packet. Okay. Again this packet loss, there is a packet loss in the wireless link. This information will not be known to the correspondent node. Okay, right? Similarly, while transmitting the packet from the mobile host to the access point through the wireless link, here if there is a packet loss, then immediately then there will not be any acknowledgement from the access point. So the mobile host itself will retransmit that. Okay, so this is how the retransmission and the actual communication happens, right? Now consider this case. Assume that the mobile host is moving from one access point to another access point. So let us say that initially the mobile host is connected with access point 2. Initially the mobile host is connected with the access point 2. Now it is moving to now it is moving from this access point to some other access point, and that is access point 1. It is moving from access point 2 to access point 1. Okay, so previously the communication was through this, right? So the wired communication is between access point 2 and the CN, and the wireless communication is between access point 2 and the mobile host. But now the things will change. Now the things will change. The wired communication should be between access point 1 and CN, and the wireless communication should be between access point 1 and the mobile node. Okay, but like how we discussed in IP, mobile IP, sometimes the correspondent node may not be knowing about this change. Sometimes the correspondent node may not be knowing about this change. Okay, so the correspondent node maybe keep sending the packet to this access point itself, to this access point itself. Okay, in that case, what will happen? This access point, the access point 2, should forward that packet to access point 1. Access point 2 should forward the packet to access point 1 so that it can transmit to the mobile node. Okay, because CN does not know that the mobile node has moved. So whenever the mobile node moves from one access point to another access point, that new access point will update the old access point. Okay, so the new access point will update the old access point, and if there is any data from the correspondent node to the old access point, that will be forwarded to the new access point so that it can reach the mobile node. Okay, but here not only just forwarding the data packets, but the socket and the socket state also should be forwarded. Okay, so this is something that is different from mobile IP. In mobile IP only the data packet should be forwarded, but in TCP the socket state and the socket port number, the socket also should be transferred, should be migrated from this access point to that access point, so that, because TCP is a connection oriented service, so that the communication happens in the same connection, so that the communication happens with the same connection, and the connection will not be disconnected. Okay, and the correspondent node does not know anything about this change and all. This changing from one access point to another access point, all these things, it will not be known to the correspondent node, and it performs this and the connection and the TCP connection will be intact. To ensure that the TCP connection is intact, this socket details also should be transferred from the old access point to new access point. Okay, so where is the correct place to keep the access point? So one of the suggestion is that with the foreign agent should be the access point. Okay, we have discussed in mobile IP there will be a foreign agent. So foreign agent, actually the co-located address, the COA address will be normally in the foreign agent. So that can act as the access point between the wireless TCP and wired TCP. Okay, or some special routers can also be deployed for that purpose, right? So this is how ITCP or indirect TCP works, right? The advantage of ITCP is it does not require any changes in the TCP protocol. Okay, all it does not any changes in the TCP protocol as used by the host in the fixed network or other host in the wireless network. Okay. All current optimization for TCP still work between the foreign agent and the correspondent host, right? Another advantage is due to strict partitioning in the two connections, that is connection between the wired port and wireless port. Transmission errors uh, on the wireless link due to that is, it may be packet loss, you cannot, or something like uh, yeah, if there is any error in the wireless link, it will not be propagated into the fixed network. Okay, without that partitioning, retransmission of the lost packets would take place between the mobile host and the correspondent host across the whole network. Now only packets in sequence without gaps uh, leave the foreign network. Okay, so so the retransmitting of packets actually becomes easier because of this partitioning. Okay, so these are some of the advantages of this particular technique. But the main disadvantage of this ITCP is the loss of the end-to-end semantics that is required from a TCP. So TCP is supposed to provide end-to-end reliable service. TCP is supposed to provide end-to-end reliable service. Okay, if a sender receives an acknowledgement, it assumes that the receiver got the packet. Whenever the sender received an acknowledgement, it assumes that the receiver got the packet. Okay. So receiving, but with ITCP, receiving an acknowledgement only means that the foreign agent received the packet. Okay. So I think it's clear. Whenever an acknowledgement is received, it means that access point, which is nothing but normally access point will be placed in the foreign agent. So it means that only the foreign agent has received the packet. Okay. The correspondent node does not know anything about the partitioning. So, so a crashing access node may also crash applications running on the correspondent node. Okay. Uh, so if the access point crashed, that is, if the foreign agent crashed, uh, then then that packet would be lost. Then that packet would be lost, but correspondent node does not know anything about that. Okay, but the correspondent node will be assuming that the packet was delivered. Okay, which actually defeats the end-to-end semantics of TCP, right? So this is the drawback with this particular technique. So the drawback is, I think it's clear. See, TCP is supposed to provide end-to-end service. Now the access point is acting somewhere in between. Okay, so if there is any data packet sent from CN to MN, first it receives the access point, that is access point or foreign agent, because foreign agent access the access point. Now the foreign agent or the access point sends the acknowledgement. Now CN assumes that the mobile node has actually received the packet, but actually mobile node has not received the packet till now. The access point should transmit the packet. But say before transmitting the packet, the access point has crashed or that foreign agent has crashed. Then this packet will not reach MN. But CN assumes that this packet has already reached. So here the end-to-end semantics fails. Okay. So this is the major drawback with this particular approach. Okay. Uh, right. So that's it about ITCP or indirect TCP. Okay. So let us stop here. Thank you.